Okay, so we were talking about infinite geometric series on Wednesday, and you can only find that infinite sum if it converges. That is, if your common ratio, the absolute value, is less than 1. And if that were the case, well, then there's your formula. We were just talking about that. Now, if it diverges, then the problem is over. You're not going to be able to find an infinite sum. You can just move on to the next one. Only if it converges will you be able to get what you're looking for. All right, so we finished up with A on Wednesday, so why don't we go ahead and take a look at B. So I have an infinite sum notation here, the sigma notation. Now this time it's starting with n is equal to 0, and don't worry about that. Okay, that's just telling me the first value to plug in order to get the first term. Okay, so here were the 3 steps. First off, we had to decide, does it converge or diverge? Okay, if it converges, we'll identify the first term, and then we'll go ahead and solve the formula. So let's see here. What is the common ratio? It is -4/5. Okay, that's my base. So -4/5. Now here's the question. Will the absolute value of a -4/5 be less than 1? Yes. Okay. Because it satisfies that one condition, that means that this sequence will converge. And only if it converges will you be able to find that infinite sum. Okay, so step 2, what is the first term? Now think back to A. What did you say the first term was there? Remember, it was 3, right? That's my scalar value. Well, the same thing over here would be 1, but even if you're not sure, plug in the first value provided at the lower limit. Okay, so if n equals 0, what is -4/5 to the 0? 1. Okay, so if I were going to go ahead and start to generate this sequence, then the first term would be a 1, and then we would just keep going. Okay, so now let's go ahead and plug in everything we have. So for 3, the infinite sum is going to be the first term. I'll go ahead and write out the formula. A sub 1 over 1 minus r. So the first term is 1 over 1. Now what happens when you subtract a negative? You add it. So I'm going to go ahead and say plus 4/5 because we would be subtracting a negative. And Jane, what is a 1 plus 4/5? 9/5. So I'm looking at a 1 over 9/5. So what should my infinite sum be, Savion, once I take the reciprocal? Bless you. 5/9. There we go. So if I were to start adding up all the terms that make up this sequence, okay, it should converge to 5/9. It's going to get closer and closer to that value. Okay, questions? Now, I talked about this on Wednesday. I'm only going to go ahead and show you one more time for those folks who are going into calculus. Let me go ahead and show you another method. Let's start with the partial sum notation. So I'm going to take sigma. Now, we're working the same problem. We're still on B. So I'm going to say k equals 0 to n. Now, remember, I can't put infinity because I'm using the partial sum formula. Okay, I'm going to add up a specific number of terms for the same problem, -4/5 to the k. Well, what I want to do is take the information from that problem, and I want to go ahead and plug it into the partial sum formula. Do you guys remember what that looks like? You'll actually be using it on your exit ticket today. Okay, what's the first term here? Well, actually, I kind of gave that away, a sub 1. But then what do you multiply that by? It's 1 minus r to the n divided by 1 minus r. There you go. So I want to take the information in this problem and I want to apply it to this formula right here. Well, we already know the first term in r, so I'm going to say the first term is 1 times 1 minus r to the n would be -4/5. That's a 5 to the n. And then I'm going to divide it by 1 minus r. So I'm going to once again go ahead and put 1 plus 4/5. But we actually just simplified this. Jane helped me out and said that 1 plus 4/5 was 9/5. So when I take the reciprocal, I should end up with a 5/9 times 1 minus negative 4/5 to the n. Okay. Now this represents the partial sum. If I were to use this, let's say I wanted to know just what the sum of the first 10 terms was, just any number. If I were to plug 10 in here and simplify, it's going to give me that sum. Okay. But now I want the infinite sum. So I'm going to use that notation. What did we do on Wednesday? We did something that started with an L. What was it? You get closer and closer to a number, we refer to that as a limit. Okay. So we're going to take the limit as n approaches infinity of this expression. But I'm just going to go ahead and put s sub n so I don't have to write it all out again. So if I take this expression right here and I start plugging in larger and larger numbers for n, what's going to happen to negative 4/5 to the n? What's that, Dylan? It's going to get smaller. In fact, infinitely smaller. It's going to approach what? It's going to approach 0. Now, it will never actually hit 0, okay, mathematically. But if you're looking at a number that's like 0.000000000000000000001, you're going to basically say that number's what? 0. Yeah, it's so infinitely small, it's insignificant. So the only thing we have left is 5/9 times 1. Well, there's 5/9. That's exactly what we got. Now remember, that's the correct notation you're going to want to use for calculus. Okay, but so if you're not going to calculus, then don't worry about that. Okay, if you are, maybe put a star by it or practice it on the assignment. You know, do something like that. Okay. All right. Well, good. Now, I'm not going to worry about doing any more of those, but let's just go ahead and use the problems. If there is an infinite sum, we'll go ahead and use the formula. Okay. So it's the same style. Now I'm going from n equals 0 to infinity for 9/10 to the n. Okay, so first off, Jack, what is r? R is 9/10. So will the absolute value of 9/10 be less than 1? Yes. So because that means this converges. That means there is going to be an infinite sum. Oh, in fact, I was just thinking, I offered this to the previous classes. That problem that we were just looking at right here, okay, specifically this section right here, some people have been having trouble seeing why this actually does go to 0. Does anybody want me to show you the graph? It's actually a pretty cool looking graph. Okay, so let me go ahead and show you. I already have it pulled up. This is negative 4/5 to the x. Why does it look like that? There you go. That's exactly right. Dylan says it's positive and negative. If you think back to Algebra 2, when you were dealing with exponentials, one of the restrictions we had was that the base had to be positive so that the graph didn't do this. But if you have an even power, you ended up with a positive result. Negative power ended up with a negative. So it's just going to bounce back and forth. But you'll notice as x is getting bigger and bigger, what's happening? From above and below, it is approaching 0. So the larger x becomes, the smaller the values are actually going to be. This is also referred to as a telescoping graph. Again, you'll learn more about those in calculus. Okay, so let's get back to this problem here. Okay, so bless you. What is the first term? It is 1, 9/10 to the 0 power. It is 1. All right, so let's find out what that sum is. So it's the first term divided by 1 minus r. Okay, well, the first term is 1 divided by 1 minus the common ratio, so 1 minus the 9/10. So what's 1 minus 9/10? Okay, 1/10. So this is 1 over 1/10. So what is my infinite sum as soon as I take the reciprocal? 10. So this sequence should converge to 10. Okay, so the more terms that I add up in this sequence, closer and closer I should get to 10. Is anybody, yes, Floss? Yeah, see, because when we did it a moment ago, see, now this just represents basically a modified version of the same formula we've been using to get the partial sum. But now, in order to get the infinite sum, you just take the limit as n approaches infinity. Yeah, it's just another way of doing it. Okay, besides that little formula we provided. Okay, let's take a look at B. We want to go from 1 to infinity for pi over 2 to k minus 1. Okay, let's see. Who haven't I talked to lately? Vrunda. What is r? Okay, so r is equal to pi over 2. Will the absolute value of pi over 2 be less than 1? No. Okay, it will not. In fact, somebody help me out. What's the decimal value for pi over 2? It's about what? Sorry, what? About 1.57, right? That's definitely larger than 1, so that means it does not converge, it diverges. That makes sense because you have a growth base, so each term is going to start to get larger. And that's it. If it diverges, you cannot find an infinite sum. So that problem is over. B is done. Okay. Everybody okay with how we knew why? Okay, and here's our last problem for today as far as the notes go. 1 plus a half plus a fourth plus an eighth plus ... Okay. Now, let me ask you a question. What's the difference between a sequence and a series? There you go. In fact, if you're looking at this, they're not giving you the summation notation on the previous problems. They're already adding them all up. So if you kind of ignore all the pluses, 1, 1/2, 1/4, 1/8, those are the original terms in the sequence. Once you start adding them up, then it becomes what we call a series. Okay. So we already know the first term is 1. Well, that's easy. What is r? It's what? 1/2. Yeah, you can just tell by the pattern. Half of 1, 1/2. 1/2 of 1/2, 1/4, and so on. Would anybody like me to take a ratio of 2 consecutive terms to show you that we're going to get 1/2? Okay. Jack, you want to see it?
No, I said nay, proceed.
Oh, okay. So if r is equal to 1/2, will the absolute value of 1/2 be less than 1? Yes. Okay, so if it fits that condition, it's going to converge, and that means we can find an infinite sum. So the infinite sum is always the first term divided by 1 minus r. What was the first term again? 1 over 1 minus the common ratio we said was 1/2. Okay. What's 1 minus a half? So 1 divided by 1/2, as soon as I simplify, it should be 2. That's what?
So in economics, there's a thing called UPC, which is
MPC?
marginal propensity to consume.
Oh, really?
Yeah, 1 over 1 minus.
Nice. See, it's really crazy how many times you come across mathematics in your daily life, but you don't realize it. But once you start to see it, then you realize just how full your life is. How rich it is. You guys are laughing more now than when I tell jokes. That's kind of bothering. Okay. All right, any questions on these problems? How are we doing? Okay. All right, so here's what we're going to go ahead and do. There is still 1 page left on your notes. We will take care of that on Monday. You should also have time to look over your assignments. What I'm going to do now, first I'm going to go ahead